Hello my dear students, this is Akash HD and welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn the Vernier calipers. The question arises, what is the need of the Vernier calipers? We can take the measurement from the normal scale also, but the thing is that the normal scale that we use in our class and all that cannot give the very accurate reading. Okay, like from that scale we can measure very accurately up to the 0.1 centimeter. If in case in 1 centimeter there is the 10 divisions. Okay, but if we want to increase the accuracy, so to increase the accuracy we have to use the Vernier calipers. Even if we want to increase the accuracy further, we have to use the screw gauge and further instruments also. Okay, but in this class we are going to learn in a very detail with questions how to use Vernier calipers and what kind of questions will come in exam and how to do those questions. Okay students, so let's start the video. So here you can see Vernier calipers VC. Let's see here. Vernier calipers is used to measure the length and thickness, internal and external diameter, and depth of the object. Like if any beaker and all is there, now we want to measure the depth and all. Okay, so students, you can see very well the Vernier calipers looks like this. Okay, you can see very well the Vernier calipers. So if in case we want to measure the length and thickness and all that, okay, so that time we will use this jaw for measurement outer diameter, to measure the outer diameter also, even for the thickness also, length also, all these things we can measure with this jaw. This is the fixed jaw and this is the movable jaw. Here you can see here this Vernier scale is there. This is the Vernier scale. Okay, and here you can see this is the main scale is there. Okay, and after that if we want to measure the internal diameter, as we can see very well, to measure the internal diameter of any hollow pipe and all that, now we will fix here. Okay, and even this is also fixed jaw and this is the movable jaw is there. If in case we want to measure the depth and all that, we have to use this stem for measuring depth and all that. Okay students, so you can see overall here, if we see overall this device, you can see very well this is the main scale, or we can tell MS. Reading of the main scale is called main scale reading, we will tell MSR. Okay, similarly this is the Vernier scale, in short form we will tell VS, and the reading of the Vernier scale is called Vernier scale reading, we will tell VSR. Okay, so if in case any object we fixed here to measure the length or thickness, we will put the object here and from here we will tighten it, so that what will happen, there should not be any loose contact and we can measure here the proper reading. So I hope so this is the very clear student. So here in this instrument we have the upper jaw, we have this lower jaws, we have the main scale, we have the Vernier scale, we have the depth measuring prong, or we can tell stem for measuring depth, and here we have one tightening screw. So from there we can tighten the object and all that. Okay students, so now we are going to see in a very detail how to take the readings and which kind of error may arise in this. Okay, and we will see the least count also. Okay, so first let's see what is the least count, because in any measurement that least count is the very important. So see here, the smallest reading which can be measured by an apparatus accurately is called least count of that apparatus. Again I am telling that here, what is that? Smallest reading which can be measured accurately is called what? Least count. Normally I am telling generally the least count for the normal scale 0.1 centimeter, Vernier calipers 0.01 centimeter, screw gauge 0.001 centimeter. Generally I am telling, but depending upon the instrument to instrument it will change. Okay, after that kindly see, least count of Vernier caliper is also known as Vernier constant. Okay, and how to define it? See, it is defined as the difference between one main scale division and one Vernier scale division. This is the standard definition. So if I write here the least count, so least count is given by here in a very short way, length of 1 MSD. MSD means main scale division, minus, okay, minus length of 1 VSD. That means Vernier scale division, main scale division and Vernier scale division. Okay students, so you have to remember this formula. Least count of the Vernier calipers is given by what? Length of one main scale division minus length of one Vernier scale division. Okay, and I have shown you very well. Here you can see some divisions are there on this scale, that is called the main scale division. Here some divisions are there on the Vernier scale, that is called the Vernier scale division is there. Okay, great. So now students, after this, if we calculate the least count, now in a very, we'll make one formula is there, okay. So students, as I have told you very well, now what is the least count? I have told you length of 1 MHD minus length of 1 VHD. Now this is the thing. After that, what happens that in a vernier caliper, we can tell very well. Can you see here? This used to given in a question and all. Length of n vernier scale division, no, VHD. Length of n vernier scale division is used to be length of n minus n main scale division. Okay, this used to be given like this. Like if in the question that you are looking at here, length of 50 vernier scale division is equal to length of 48 main scale division. Okay, that means n value is the 50 and small n value is how much here? 2, because 50 minus 2 is the 48. Is it like that we have to do here? Okay, so from here students, if I go here, I am going to calculate length of 1 vernier scale division. Okay, so we can write here students, can you see here? Length of 1 vernier scale division is given by what? Can you see here? Length of n minus n by n, okay, main scale division. Okay, after that what we can write here, can you see very well? We can write here n minus n by n into length of 1 main scale division. Okay, like I can give the example, like we can tell price of 4 apple, or we can tell 4 into price of 1 apple. Getting what I am telling? Price of 4 apple or 4 into price of 1 apple. In the same way, we can tell length of n minus n by capital N MHD, or we can tell n minus n by capital N into length of 1 MHD. Okay, this thing is the clear. After that students, please remember that here I have taken here, let length of 1 MHD, very very important, is x. What is x? Length of 1 MHD I have taken here x. Okay, so after that what can I write here? Can you see here very well students? See, now this least count is given by, see here, this is the main formula, this is the main formula, no? This is the main formula. So what is this? Length of 1 MHD minus length of 1 VHD. So length of 1 MHD, this is the length of 1 MHD. How much I have taken here? X. I will write here x minus here length of 1 VHD is given by here n minus n by n. Can you see here? N minus n by n into length of 1 MHD, and that already we have defined how much is there? X. Okay. After that what I will do here students, here I will take here x common. So I can write here 1 minus n by n into x. Is it? Can you see? Very well. After that what will happen that here? If you will take here the LCM n, then we can write here n minus n, is it? And here into x. Okay. So when you will multiply minus inside, so it will come here n minus n plus small n. Is it? So students, when I will simplify this, now kindly first see here very well how we have done this. Is it? So if I will write here the final expression, students, it can write here after simplification. When you will do all this calculation, it will come here n into x by capital N. This is the least count formula of the Vernier Calipers. Very important formula. Okay. And students, what is this? What is n? N is the, I am telling that here, number of divisions on a vernier scale. Okay students, remember that. What is x? X is a length of 1 MHD. Okay. Now students, after that if I take here one example, general example. So in a normal vernier calipers, what happens used to be there? They used to tell students here, length of 10 VHD is equal to length of 9 MHD. General vernier caliper I am talking about is there. Okay, general vernier caliper. Put the star sign. Okay. So students, here you can see very well. If I will compare this, no, very basic thing. If I will compare with this, what I have told you, see, length of 1 VHD is equal to, what I have told you, length of n minus n MHD, correct? So students, if you will compare here very well, okay, so if you will compare here very well, what will happen that here, see, the value of n is how much? 10, okay. After that, see, this n minus n is there, na? Even this 9 I can write here 10 minus 1. Kindly understand it very well, okay. So already n is the 10, small n value how much is there? Small n value is the 1, okay. And the length of 1 MHD, they used to give how much? Length of 1 MHD, students, they used to give here 1 mm, or we can tell 0.1 centimeter. Na? Normal scale. Normal scale is there, na, that we use in our school and all that, na, that one here. Length of 1 MHD. Normally, generally, okay. So students, if I write here the formula, it will come here, least count equal to n means 1 into x value, what is given here? 0.1 centimeter by 10, okay. Then when you will simplify this, it will come here how much? 0.01 centimeter. If nothing is given, we can use this value, okay. If in case, students, I will use here the second example, okay. Let's take for example, if in case they have given is like this, length of 20 vernier scale division is equal to length of 18 main scale division. If in case they have given like this, okay, then what will happen, dear students? Now guess please very well, n is the 20, is it? Small n, because you can write 18 means 20 minus 2, is it? So small n is 2, okay students. And after that, let's take x, nothing is given, so 0.1 centimeter, okay. So from here, if I write here the least count, any value can come, again I am telling that, any value can come. Then what this will happen that here, we know the formula n into x by n, so small n is 2, x value how much is given? 0.1 centimeter, okay, and capital N is 20, is it? So when you will simplify this, what is coming is there? 0.01 centimeter. It does not mean that always it will come 0.01 centimeter, but okay, this kind of situation has created, so only here answer is coming how much? 0.01 centimeter, okay, great. Now students, if I write here this one, measured value. Measured value means error may be also associated in this, okay. So please remember that here students, this measured value, now measured value, or we can tell MV in short form. This measured value is given by main scale reading MSR plus Vernier scale reading. Vernier scale reading, okay. This formula you have to remember that here, and please remember that here, this Vernier scale reading is always given by n into least count, where what is n, you can see very well. Next I will tell you, but see this, n is the division number of Vernier scale which is coinciding with the main scale division. You can see very well. What is n? N is the division number of Vernier scale which is coinciding with the main scale, okay. Where n is see here, where I am writing here, n is the division number of Vernier scale which is coinciding with the main scale. Okay students, this thing you have to remember that, okay. When we will solve the question, then things will become very clear, okay, great. Now students, after that, if we write here the true value or the actual value, because what will happen that measured value will be with the error. So if we want to remove the error, then what we have to do here, please remember the formula is there. The formula is that this true value or actual value is given by what, students? It is given by, see here, measured value minus 0 error with sign. 0 error with the sign. With the sign, very important. Now, because when negative 0 error is there, na, we have to put here with minus sign. Positive 0 error is there, na, we have to with plus. Okay. So remember that here. So what is the measured value? It is given by anyhow. See here, please, MSR plus VSR minus 0 error, JEE, 0 error with a sign. Very important, students, 0 error with a sign. Okay, great. We have seen the measured value and we have seen here, students, true value. Okay, now we are going to see how to, what is the 0 error and what kind of error is there. Okay, so here please, students, 0 error is defined as the condition in which measuring apparatus registers a reading when there should not be any reading. Okay, the reading is not there. Even later we will see when the fixed jaw and movable jaw are in contact, we did not put any object between fixed jaw and movable jaw. That means we are not measuring anything. That means it should be 0. But what will happen that here? Because of this error, the vernier calipers will give some reading. Okay, the reading should not come, but still it is coming. Okay, so that is called what? That comes under the 0 error of the VC. You can see very well the condition in which the measuring apparatus registers a reading when there should not be any reading. Okay, great. Now students, see, there are two types of 0 error. There are two types of 0 error. Let's see first one, positive 0 error. What is this, students? Here the positive 0 error. It is given by when fixed jaw and movable jaw of vernier caliper comes in contact. See here please, we are going back side. See here, this is the fixed jaw, this is the movable jaw. Both will come in contact. Both will come in contact. So that time what will happen that here, when both are coming in contact, students, then you know what will be there? There no object. That means it should be 0. But what will happen that here? If there is a no object between fixed jaw and a movable jaw, then what will happen? The 0 of the main scale and 0 of the vernier scale, that will coincide. That means there is a no error, no 0 error. But what will happen that in case of the positive 0 error, then 0 of vernier scale is right of the 0 of main scale. Kindly see very well, when fixed jaw and movable jaw of VC comes in contact, then 0 of vernier scale is right of the 0 of a main scale. Okay, I can see very well here. Let's take for example is there. No? I have taken here some 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Like this I have taken. Okay. And let's take for example, this is the 0, this is the 1. And students, let's take here, this is the main scale. So what will happen that here, in case of the no error, in case of no error, what will be there? You know what will be there? The 0 will be here. 0 will be here. Okay. The 0 of the vernier calipers will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Something like this is the vernier scale. Okay. So if this kind of situation is there, we can tell there is the no error, no 0 error. In this situation, what is there? The students say this is the no 0 error, because 0 of the main scale and the 0 of the vernier scale, what is this, students? They are in the same line. Okay. But what will happen that here, if in case there is the positive 0 error, that time what will be there? The 0 of the vernier scale is which side? Right side. That means we can tell students it will happen that like this. Let's take, see, like this it will happen that here. See, this is, you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It can be more also, but here this is the 0 of the vernier scale. Now what will happen that here, if you will see, 0 of the vernier scale with respect to 0 of the main scale is which side? Right side. Right side. Okay. So in this situation, students, what will happen that here, if you will compare this one and this one, here what will be there? Here will get here the error. Which error is there, students? Here this is the positive 0 error. Which error? Positive 0 error. 0 of the vernier scale is the right side of the 0 of the main scale. Okay. And this positive 0 error is given by here n into LC, n into LC, and that n we have seen before also. What is the n, students? Can you see very well? Where n is the division number of vernier scale, which is coinciding with the main scale division. Okay, I hope so you have understood very well. Okay. Second one is there, students, negative 0 error. What is this? See, when fixed jaw and movable jaw of vernier calipers comes in contact, then 0 of vernier scale is left of the 0 of main scale. Okay, left side. Okay, so what will happen that here? Again, I am taking that here. Let's take 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, like this. And what is this? This is the main scale. So when fixed jaw and movable jaw are in contact, then you know what will happen that here? Like this kind of situation will happen that here. See, this is the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this it will continue. This is the vernier scale. So you can see very well, if this is the vernier scale and observer is seeing like this, what will happen? The 0 is the which side? Left side. 0 is the which side? Left side. For positive 0 error, with respect to 0 of main scale, 0 is the right side. But for negative 0 error, with respect to the main scale, 0 is which side? Left side. Now have to be very, very careful. Okay. And when we have to write here the negative 0 error, it is given by what? Total vernier scale division minus n into LC. And this one we have to put with sign. That means after calculating this, here we have to put with minus sign also, because the name is the negative 0 error, and then we have to put in a formula. Okay, great. Now see here, where n is the division number of vernier scale, which is coinciding with the main scale division. Okay, students, so you can see very well in this diagram, we have seen the negative 0 error. Okay, great. Next one you can see, now we are going to solve some questions. Now, some questions are there. See, JEE 2024 question is there. The assertion is, see here, in vernier calipers, if positive zero error exists, then while taking measurements, the reading taken will be more than actual reading, because you know very well true value means measured value minus zero error is sign, So if in case zero error is there, then that time measured value will be more than the true value. Okay, and to get the true value from the measured value, we have to subtract this positive zero error. Okay, so when the vernier caliper is having the positive zero error, that means what is this? The zero of the vernier scale is what? Right side of the zero of the main scale. That time measured value will be more than the actual value. Okay, that they are telling that, and here what is this? This assertion is the correct. Okay, second one, what is there? Here the reason the zero error in vernier calipers might have happened due to manufacturing defect or due to rough handling. Okay, this is the information is there, that is the also correct. Okay, but anyhow this reason is not the correct explanation of the assertion. Okay students, so what will be there? The correct answer is going to be the option B is there. Okay, assertion, reason both are correct, but reason is not going to explain the assertion completely. Okay, great. Next one students, we are going to see this question came in a JEE 2024. Can you see here? If 50 vernier divisions are equal to 49 main scale divisions of traveling microscope and one smallest reading of main scale is 0.5 mm. Okay, the vernier constant of traveling microscope is how much? Okay, so students, please remember that one thing. By saying this, I can write here, see, according to me, if I see the question, I will see here length of 50 vernier scale division is equal to how much here? Length of how much students here? 49 main scale division. Okay, after that, if I will clarify these things, I will see here the capital N value, I will get here the 50. Okay, and 50 minus 49, even if you want to get the value of N also, no, you can write 59 as a 59, you can write here as a 50 minus 1, or if you want to get the value of small n, just subtract it. 50 minus 49, 1. Okay, directly also we can get here, we can write like this also, 50 minus 49, what is coming? 1. And after that, what is the value of the x? That means length of 1 mhd. How much is there? See, smallest reading of main scale is how much here? 0.5 mm. Okay, it does not mean always like it is the 0.1 centimeter 1 mm. Okay, it can be anything. See here they have given 0.5 mm instead of 1 mm, they have given how much here? 0.5 mm. Okay, so students, after that, if I write here the formula, what is the formula? Least count formula, n into x by n. N value how much is there students? We have got here 1 into x value how much is there? Can you see very well? 0.5. And here they are telling the answer, all the answers are there in a, okay, first we'll solve here, okay, no problem here. 0.5 mm by capital N value how much is there? Capital N value is the 50. Okay, so what will happen that students? 0.5 by 50, remove the decimal, so it will come here how much here? 5 by 500 mm. Now unit is very, very important. So 5 by 500 mm, how much is there? 1 by 100 mm, and 1 by 100 mm means we can write here 0.01 mm. Okay, 0.01 mm. Any option is matching there? 0.01 mm. Yes, students, you can see very well the correct option matching is there, option D. Okay, so you can see very well in how much beautiful way we have done this. Okay, like this we have to do it. Next one, students, again little bit different kind of question is there now. Let's see. Okay, so see here, a traveling microscope is used to determine the refractive index of a glass slab. If in case you are in 12th, in a lab you will see that under the practicals. If 40 divisions are there in 1 centimeter on main scale and 50 vernier scale divisions are equal to 49 main scale divisions, then least count of the traveling microscope is how much? Okay, so it was just like a previous question. Now what they have given, 50 vernier scale divisions are equal to 49 main scale divisions, correct? So what is their students here? This n value is given here 50, and small n, what I have told you before also, just subtract like this, 50 minus 49, you can get here 1, no problem. But the thing is that what is the value of the x? That is the main thing. Okay, so see here, what is given? See, read the question. 40 divisions are there in 1 centimeter on main scale. Now in 1 centimeter, how many divisions? 40. Okay, so the length of 1 MSD will be 1 by 40 centimeter. What will be there? 1 by 40 centimeter. Because see, 40 divisions can measure 1 centimeter. So, one division can measure how much here? Kindly see very well. 1 by 40 centimeter. Getting? That's why I have written here. What I have written here? This one here. 1 by 40 centimeter. Okay. Now, students, just we have to write here the formula. So, what will happen here? Least count equal to again n into x by n. Can you see very well? Here it is given in a meter. So, I have to be very careful. So, n value is the 1. X value how much is given? 1 by 40 centimeter means into 10 power minus 2. This is the value of the x. Okay. And capital N value how much is given is there? Capital N value is the 50. Okay. So, see into 1 by 50. This is the capital N value. Capital N value how much here? 50. Okay. So, students, what this will come here? If I will do here, it will come here. See, 5 4 20. This zeros into 10 power minus 2. Okay. After that, what will happen that here? Again, we'll simplify this is there. Okay. So, students, I can do here, see, 1 by 2 into 10 power. This 10 power 3, it will go in the numerator. It will become here 10 power minus 5. I can write 10 by 2 into 10 power minus 6. Correct, na? 10 power 1. That means how much? 5 into 10 power minus 6 meter. That means what we have to fill here, students? We have to fill here 5. Okay. So, remember that here, the value of x have to be very, very careful. In a question, the value of x, you have to think very well. Okay. Now, students, the next question is here what? NEET 2024 question, little bit conceptual here. In a Vernier calipers, n plus 1 divisions of Vernier scale coincides with n divisions of main scale. If 1 MSD represents 0.1 mm, then Vernier constant in centimeter is how much? Okay. So, students, can you remember that here one thing? What is the value of the x is given? The value of x they have given here 0.1 mm. Okay. You know very well 1 mm means 10 to the power minus 1 centimeter. Okay. So, I can write here even see 0.01 centimeter also. Okay. And the next thing is very, very important. What is this here? Length of n plus 1 Vernier scale division is equal to, students, here length of n main scale division. Can you see somewhat difference is there? Before that, what I used to write here? I used to write here length of n Vernier scale division. But now what is given? N plus 1 Vernier scale division. Okay. So, have to be very careful. What is this here? This least count is given by formula n into x by n. But here this n will not put here. Why? What is the value of the small n? Take the difference. N plus 1 minus n. How much is there? N plus 1 minus n means 1 into x value. How much is there here? 0.01 centimeter. Now, instead of n, what we have to put here? This n plus 1 Vernier scale division. Okay. So, n plus 1. Okay. So, when students you will simplify this, it will come here what? 1 by 100 into n plus 1. And they are asking here in a centimeter. Okay, so here centimeter is there. Which option is correct is there? So, can you see very well? Option B is the correct answer. Okay. So, before that we used to write n Vernier scale division. But now what is given? N plus 1 Vernier scale division. That's why we have put here n plus 1. Okay. I hope so you have understood very well. Okay. Now, students, you can see very well. Now, this is the question. This is the question here. Now, this is the JEE 2022 question. Question is only looking bigger, but when you will solve it, it will be very, very easy. Okay. So, just let me see here. See. In a Vernier calipers, 10 divisions of Vernier scale is equal to 9 divisions of a main scale. Okay. After that, see. When both jaws of Vernier calipers touch each other, then 0 of the Vernier scale is shifted to the left of the 0 of the main scale, and 4th Vernier scale division exactly coincides with the main scale reading. So, students, up to this they have given to calculate the 0 error and all that. Okay. And what is given? One more thing. 1 main scale division is equal to 1 mm. Okay. So, with this much information, students, with this much information, we can calculate the least count. Even we can calculate the 0 error also. Okay. So, first let me calculate here the students 0 error. Okay. So, see here. So, first one, if I calculate here the least count. So, see n into x by n. What is n? They have given 10 divisions of Vernier scale is a 9 main scale division. So, 10 minus 9, how much is there? 1. Value of x, how much is given here? If you will see very well, they have given here, see here, equal to 1 mm. answer is given in a centimeter and all, na? So we'll convert into the centimeter. 1 mm means what is this? 0.1 centimeter. What is the capital N value? The capital N value is 10. Is it? So what this will come here? It will come here 0.01 centimeter. Na? Least count is done. Now after that, we have to see positive zero error or negative zero error. See, when fixed jaw and movable jaw are in a contact, then what is this? Left of the zero of the main scale. Left side. Left side means which error? Negative zero error. Okay. And which division is coinciding is there? See, this fourth division is coinciding. Okay. So when I will write here the negative zero error. What is this, students? Negative zero error. What is the formula I have taught you? Total Vernier scale division minus small n. So we will write total Vernier scale division 10 minus 4 into least count 0.01 centimeter. So what this will come here? It will come here 0.06 centimeter. This is the negative zero error. Okay, up to this the things are done. Now we have to go ahead in a question further. Negative zero error is that also clear. Now see, while measuring diameter of spherical body, the body is held between two jaws. It is now observed that zero of Vernier scale lies between 30 and 31 divisions of the main scale reading. Okay, this one will give us the main scale reading. After that, what is given there? See, and sixth Vernier scale division exactly coincides with the main scale reading, the diameter of the spherical body, how much. Okay, so with the yellow color, we will calculate here the main scale reading. With this pink color, whatever color now, we will calculate here the Vernier scale reading. Okay, so remember that here which division is there? Between 30 and 31 division. Okay, so we have to always take here the smaller division. How many divisions? 30 division. And one division, how much here? 1 mm. Okay, so what will happen that here? When I will calculate here the main scale reading. Main scale reading, how much is there? 30 divisions. 30 into least count. Least count, how much is there? 30 into this 1 MHD. No? Because between 30 and 31 division. Na? So 1 MHD, 1 main scale division is the 1 mm. So 30 divisions means 30 into 1 mm. Okay, 30 into 1 mm. Or what we can write here, can you see here? 30 into 0.1 centimeter. How much is coming? 3 centimeter. This is called the main scale reading. How much students say? This is called here the main scale reading. After that, if I will write here the Vernier scale reading, what I have taught you? N into LC. Now, what is given here? Which division is coinciding here? The sixth division. Sixth division is coinciding. Okay. So here we will write here 6 into LC means 0.01 centimeter. And what this will come here, students? It will come here the 0.06 centimeter. Okay. So now we have got here the negative zero error. We have got here the main scale reading. Remember that here always lower division counter into 1 MHD. That will give us the main scale reading, and VSR also we know. So now students, after that, if I write here the true value, what we are going to get? A true value. True value means main scale reading plus Vernier scale reading minus zero error with sign. Zero error with sign. Is it? So students, main scale reading how much here? 3 centimeter. Okay, so 3, everything in centimeter, plus Vernier scale reading how much is there? 0.06 centimeter minus zero error with sign. Now in question you have seen that the zero of the Vernier scale is the left. Left means which error? Negative zero error. Okay, so here you have to put this value with the minus sign. So minus 0.06 centimeter. Okay, so what this will happen at here? You can simplify this. 3 plus 0.06 plus 0.06. So it will come here 3.12 unit centimeter. So students, you can see very well the true value is coming here 3.12 centimeter. Okay, let's see. Let's see. That's the correct answer, 3.12 centimeter. See, there is no other options and all is matching now. So we'll take here the nearby value. And the correct answer is going to be how much here? Option C. So students, in this JEE 2022 question, you have seen very well how to see the least counter, how to calculate the zero error, either negative or positive. Here left side means negative zero error, and then we have seen how to see the MHD value. Now X value how much is given here? 1 mm. Then after that, with the yellow and this pink color marker and all, you have seen how we have calculated this diameter of the spherical body. Okay, this also you can see one time very properly. Okay, great. Now students, one more thing is there. This question, JEE 2023 question is there. Na? We will just go through it. Na? Already we have learned all the things and all. Na? But see, in an experiment with Vernier calipers of least count 0.1 mm, even they have given in a question 0.1 mm, they have given the least count. Okay, when two jaws are joined together, the zero of Vernier scale lies right to the zero of the main scale. Right, that means which error? Positive zero error this time. Okay. And sixth division of Vernier scale coincides with the main scale division. Okay. So students, with this data we can calculate here the error and all that. Okay. So now we'll calculate here the error. Least count, how much they have given here, students? See the least count. Least count they have given 0.1 mm. Is it? But let's see which kind of options are there. Options are in a centimeter. Okay. So before itself we'll convert into the centimeter. It will be 0.01 centimeter. Okay. After that, which error is there, students? Positive zero error. Positive, because which side? Right side. Given by n into LC. Is it? Which division is coinciding here? See here. Sixth division. Sixth division is coinciding this here. Sixth division. So directly we'll use the formula here, 6 into LC. So 6 into 0.01 centimeter, how much is coming? 0.06 centimeter. That is the positive zero error. Our work is done. Now we'll come to the measurement. Now what they have done after that. Okay. Let me change here the color. See. Now the measurement. So see here. While measuring the diameter of a spherical bob, the zero of the Vernier scale lies in between 3.2 centimeter and 3.3 centimeter marks. Okay. This is for the main scale reading. In the previous question, they have given the divisions. That's why we multiplied with the MHD, length of 1 MHD. But here directly they have given the value. So MSR is going to be the 3.2 centimeter. There is no doubt in that. Okay. And see. And fourth division of Vernier scale coincides with the main scale division. The diameter of the bob measured, how much is there. Okay. So main scale reading you can see very well, 3.2 centimeter. Vernier scale reading means 4 into LC, because what is given here? The fourth division. Okay. So if I write here, students, see, the main scale reading is how much here? See, how much here? 3.2 centimeter. No? Lower one will choose here. 3.2 centimeter. And Vernier scale reading, how much is, students, here? N into LC. Which division is there? Which one? Fourth division is there. See here. No? So fourth. So what is coming is there, see, the 4 into 0.01 centimeters. How much coming? 0.04 centimeter. Okay. Now after that, students, if I write here the true value, what is the formula? Again I am writing here, MSR plus VSR minus 0 error with sign. Is it? So MSR, how much we know? MSR 3.2 centimeter, everything is centimeter, plus Vernier scale reading, how much is there? 0.04, okay, minus 0 error with sign. Which kind of error? Positive 0 error. Why? Because now the 0 of the Vernier scale is which side? Right side. That's why positive 0 error. How much is there here, students? 0.06. So when I will simplify this, what this will come here, see, 3.24, 3.2 plus 0.04, even you can write 0 also, minus 0.06. So when you will simplify this, it will come how much here? 3.18 centimeter. Can you see very well whether I think so calculation is correct only? Is it? So when we will go to the back side, what we can see, the correct option is here. Option C is the correct answer. Okay, JEE 2023 question. So students, I hope so. This Vernier caliper based video you have understood very well. Keep studying, keep growing.